Hello everyone, welcome to Wave Optics and Semiconductor Physics course. I'm Dr. Santosh Kumar Alla. Today we are going to discuss about superposition principle. So before that, just try to recollect. So while wave is transporting energy from one place to another place, the particle doesn't move, but so there is a oscillation of particle occurs. This oscillation depends upon the type of what wave. That means, for example, if you see the crust is coming here, then this duct is moving up. Whenever the crust is coming, then the duct is moving down. That means the particle, okay, isn't this particle moving up and down. When crust part interacting with this particle is going up, when drop interacting with this particle is going down. So it depends upon the what phase of the wave interacting that particle based on the displacement along y-axis, it is in vertical direction, it takes place. So let's say, for example, this part, if you come to this part, this is going up. If you come to this part, it is going down. Okay, like this, it is different. Now, what superposition principle will say is that like this, if the in a particle one wave is coming, like that, if it is more waves are coming, then what is the resultant displacement of that particle? So let's say in this figure, in the previous figure, it is a dust. What is the displacement? Displacement is going high or low. When two waves, not only two, more than two waves, then what superposition principle suggests that the resultant displacement of the wave is algebraic sum of the displacements of the individual waves. Algebraic sum means either displacement of individual waves, the summation of the individual subtraction. Okay, so that we can see from this figure easily. For example, wave one, this is traveling in this direction, and wave two, this is traveling in opposite direction. When these two are coming here, okay, it is coming here. Whenever these two are meeting at this point, then what will happen? The resultant wave, one new wave has created. That new wave, what is the displacement of that new wave is sum of the two waves. That means y1 plus y2. So this is one. After interacting that, again, this wave is going in this direction and this wave is going in this direction. Like this, it is going. It's a natural process. Similarly, if the wave 1 is like this, but here wave 2 is in opposite phase, that is 180-degree phase. When these two are meeting at this point, okay, now at this point, what will happen at this point when these two are meeting? Y1, here this is more, y2 is more, y1 is less. That means so sum of y2 minus y1. So this phase is more. Okay, this amplitude, this displacement in 180-degree phase is more, so that the resultant wave is simply it is the addition, vectorial addition. So that's why we call it as a algebraic sum. So resultant wave is this. Again, this pressure passing again, then this wave is going like this, and this wave is going like this. So from this figure, it is clearly saying that superposition principle acting at a one point, only this point only, at this point only, the resultant wave created. One new wave is formed. This is the new wave. Here, this is the new wave. This wave, created wave, having what displacement? The displacement is sum of the algebraic sum of the displacements of the individual waves. This is what superposition principle. See here, wave 1. So it is in same phase. These two are same phase. So this displacement y1, y2. So add these two resultant waves like this. If it is the displacement is like this, another displacement is, if they both are same but opposite 180-degree, then what will happen? This is plus, for example, plus y1. Here, this is minus y1. So these two are cancelled. There is no resultant wave. There is no resultant. So this is what we can see. So this image, see here, when these two are meeting at this place, again it is going maximum displacement. Again, it is going in the direction. Now let's see. Can we find resultant display amplitude. Resultant amplitude. For example, wave 1 is coming in one direction. So wave 1 is coming in this direction like this. Wave 2 is coming another direction. Okay, so this is in this direction. When these two are meeting at one point, let's say at this point, now here, the resultant wave created. The resultant wave is at this point, the resultant wave is this. So wave 1, equation of wave 1 is equal to y1, a1. Amplitude is, this amplitude is a1. This is a1. And this amplitude and phase, there is a 0 degree phase. It is started at this point. Okay. And y2, the amplitude is a2. Let's say it is a2. Then phase, at this point, the phase is pi. The phase is pi. So phase difference pi minus 0 is pi. So phase is pi. That I don't know whether it may be 0 or maybe 180, it may be 90, anything. So let's say it is pi. So then resultant wave is generated. Now this wave, what is the equation for this wave? This wave equation y is equal to same form because wave equation is same. So what is the here for second wave amplitude A2, first wave amplitude A. This is resultant wave. That amplitude, let's say it is capital R. That is the resultant amplitude. So for same form sine omega t plus. So here the resultant wave may not be the same neither phase of wave 1 or neither nor wave 2. It is a different phase will be there. That phase we can say it is a theta. So resultant one different amplitude and different phase is there. This is the resultant wave. So this, what is the R value and what is the theta value that we are going to find. Okay. So mathematical derivation is there that we will see. So if you solve all these things, wave equation is like this. Resultant wave, capital R sine omega t plus theta is. What is the displacement? First wave y1, wave 2 is y2, resultant wave is y. Amplitude a1, a2. So resultant amplitude, if you derive the equations, then you will get a1 square plus a2 square is 2a1, a2 cos phi. That means the resultant amplitude depends upon what? The individual amplitudes of the two waves as well as phase. Phase difference between the two waves also it depends. Now phase 1, the phase is 0, 0, but here for this wave it is tan inverse of. Again the phase is also depends upon the amplitudes and the phase difference. Okay. Now how these equations, how these are arrived? How can you say? So these proofs we will see in the next.
According to superposition principle, if it is a particle in a medium and now on that particle, so there are different waves are coming. Let's say this is wave 1 acting on here and wave 2, let's say wave 2, so this is also is acting on this at this point, and also you take wave 3, there is another wave, it is also coming and it is also acting at this point. Then what is the resultant displacement of this particle? That particle is the resultant displacement y is equal to, it is y1 algebraic sum of the displacement of the individual displacements of the waves. That means the here y is equal to y1 plus y2 plus y3 is the individual displacement of the wave. That means displacement of the wave 1, this is y1, displacement of the wave 2, that is y2, displacement of the wave 3, that is y3. It is an algebraic sum, either it is plus or it is minus, depends upon the what is the phase of that waves. Example, two waves, that is wave 1. So this wave 1 acting on this point, the displacement of this wave at that point is y1, and If you take another wave, the displacement of that wave is from here, it is y2. So when these two waves acting at this point at a time, that means that pictorially we can represent like this. So this is wave 1 plus another wave, that is this one. So this is displacement y2, this is displacement y1. When these two are in same phase, then what will happen? The resultant displacement there is, it becomes high. That means it is a y1 plus y2. That means what will happen? This particle moves from here to here. So it is going up, the displacement. That we can represent by using this thing. So this amplitude is y1 plus y2. So this is the one way. Other example, wave 1 is like this. The displacement is y1. Wave 2 is small. The displacement is y2. That resultant wave is always should be like this. So this displacement of the particle here, y1 minus y2. So this is small, this is larger. The subtraction is, that is why the displacement particle is here very less. So it is either y1 plus y2 or y1 minus y2. That's why we say it is resultant displacement of wave y is equal to y1 plus or minus y2, or we can call it as algebraic sum. Let's consider two waves. Okay, two waves. A wave equation y1 is equal to amplitude a1 sine omega t, and the phase is 0. Let's say it is 0. Another wave y2 is equal to a2 sine omega t plus the phase difference is 5. Let's say two waves. These two are getting superposed, are meeting at one point. This is like a1, one wave, another wave if you take a2. So I don't know what is the phase of these things. Then if these two are meeting at one place, according to superposition principle, y is equal to y1 plus y2. That means a1 sine omega t plus a2 sine omega t plus 5. That is mathematically this one. And now it is equal to a1 sine omega t plus a2 into, if you expand this one, sine omega t cos 5 plus cos omega t sine 5. So this is the expression. Now let's expand this one. Y is equal to, so if I take sine omega t is common, sine omega t is here, a1 is left, here a2 cos 5 left, a2 cos 5 plus cos omega t. If we take cos omega t, what is left? a2 sine 5, a2 sine 5. And now let r cos theta is equal to a1 plus a2 cos 5. R sin theta is equal to a2 sin 5. So just I am simply taking two things here. Okay, now what will happen? This equation becomes y is equal to, this is r cos theta into sin omega t plus this is r sin theta into cos omega t. So this equation becomes, now it is, we can write it is cos theta sin theta cos theta sin theta 1 cos theta 2 cos theta 1 sin theta 2. That it can write r sin omega t plus theta. So this is the final equation for this one. Now we have to find what is r, so what is theta. So these two things we have to know. Similarly, r sin theta is equal to a2 sin phi. So this is what we have seen. Okay, so now from these two equations, if I do square, okay, so let's say this is equation 1, this is equation 2, then if I do 1 square plus 2 square, then what will happen? R square cos square theta is equal to a1 square plus a2 square cos square phi plus 2a1 a2 cos phi, and another equation r square sin square theta is equal to a2 square sin square phi. So if you add these two equations, then what will happen? We got r square here, cos square theta plus sin square theta is equal to here a1 square plus, if you take common in these two, a2 square is common. If you take a2 square is common, cos square phi plus sin square phi plus what is left? 2a1 a2 cos phi. And now it is cos square sin square theta is 1, so r square is equal to a1 square plus, this is also 1, a2 square plus 2a1 a2 cos phi. So this implies r is equal to square root of a1 square plus a2 square plus 2a1 a2 cos phi. So this is the value of r we already derived. Now only one thing is left. What is theta? Resultant amplitude anyway we got, so now we have to find what is theta. If you want to know theta, then what we have to do? 1 by 2. If you do 1 by 2, then what will happen? R cos theta by R sin theta is equal to a1 plus a2 cos phi by a2 sin phi. Then it becomes r will get cancelled. This is cot theta. So this is cot theta is equal to a1 plus a2 cos phi by a2 sin phi or phi. If you write tan theta is equal to a2 sin phi by a1 plus a2 cos phi. So therefore theta is equal to tan inverse a2 sin phi by a1 plus a2 cos phi. So this is theta, and this is theta, and this is r. These two things are very needed because y is equal to final expression what? ar sin omega t plus theta. So the unknown things are theta and r, so that we derive from the what are the amplitudes. We know the amplitude of wave 1, wave 2 and as well as phase difference. So from this r we can get, at the same time theta you will get, so that you can find the resultant displacement from this equation. This is about superposition principle. Now in this we consider different cases are there. Let's see the different cases. Superposition principle, what happened? One wave is coming like this. The amplitude of this wave is what it is? A1. Okay. So another wave, let's say another wave is coming. So that also acting at this point. That means the amplitude of this wave is, so total amplitude is A2. Then because of these two superposition, then one resultant wave is generated. So now the resultant wave is amplitude is r. That r is we can find by using this equation. R is equal to a1 square plus a2 square plus 2a1 a2 cos phi. So always this is depends upon the phase angle. That means whether two waves are in same phase whether two waves are in opposite phase, that matters. Based on the resultant wave is generated. So let's say what will happen. If you take the case 1, consider that when these two waves are in same phase like this. Same phase means phase reference is 0. Also if you take A1 is equal to A2, that means amplitudes are identical. Let's say that wave amplitude is A. That means two waves are having same amplitude in the same phase. When these two meet at a one point, then what is the resultant wave? That means first we will find what is the resultant amplitude. Resultant amplitude R is equal to, it is from this equation, A1 square plus A2 square. A1 square plus A2 square means A square. So A square, A2 square is also A square. 2, A1 means A, A2 is also A. Cos phi is equal to 0. That means it is 1. So then what is this equation? A square plus A square, 2A square, then it is a 4A square. Then what is it is here? It is 2A. So resultant amplitude is 2A. That means wave 1 is A, wave 2 is also A, amplitude is also A, then resultant wave is like this. So this is 2A. Now in optics, so if you remember, intensity is directly proportional to square of the amplitude. So now if you take proportionality constant, I is equal to square of the amplitude means A square. So amplitude square. So here in this case I is equal to amplitude of, for this condition, R square. This is equal to 4A square. So this amplitude is always maximum. This is called maximum intensity. Intensity is always maximum. So and this amplitude is also called maximum amplitude. Maximum. So more than this amplitude cannot occur. So this is the case for maximum amplitude or maximum intensity. Case we have seen same phase, phi is equal to 0. Now if you take different opposite phase, that means phase is wave 1 amplitude is A, another wave, it is also acting at the same point, that amplitude is also A, but phase is different. So phase is different. Then what is the resultant wave? That we will see. So like this, if the two waves are like this, that means what is the phase difference? We can say it is a 180 degree phase difference. Then what is the resultant amplitude? R is equal to, according to formula, A square, A1 square means A square, A2 square means A square, plus 2A into A, cos phi, cos 180. So cos 180. So now it is A square plus A square is 2A square, plus this is 2A square. Cos 180 is minus 1, then it becomes minus, then R is equal to 0. If R is equal to 0, intensity is equal to R square, that is also 0. So I intensity is 0. So this is called minimum intensity condition. When two waves are having the same amplitude and having opposite phase, that means what type of wave is coming here? Wave 1 is A, wave 2 also A, the resultant wave, there is no wave. See here, wave is missing. That means energy getting dissipated. There is no wave. Intensity 0 means energy becomes 0. Right? This is the case 2. So similarly, you can find angles also by using this relation. Case 3, here I just only take A1 amplitude, A2 amplitude, two waves within the same phase. That means only phi is equal to 0. But A1, A2 are the different amplitudes. In that case, what will happen? R is equal to square root of A1 square plus A2 square plus 2A1 A2. So that is equal to A1 plus A2 whole square. So then the square root will cancel. So R is equal to A1 plus A2. That is the resultant amplitude. Then what is the intensity? I is equal to A1 plus A2 whole square. So this is resultant intensity. So this occurs when then phi is equal to 0 degree. What happens in the same case when there is phi is equal to 180 degree? So that we take it as a case 4. So case 4, if you take, so two waves we're having the different amplitudes A1 and A2, but phase difference is 180 degree. That means phi is equal to 180 degree. Then in this case we can just simply write directly, you can write A1 square plus A2 square minus 2 A1 A2. So then what will happen? This is simply, it is A1, because A1 minus A2 whole square, so square will get cancelled, square root. So therefore R is equal to A1 minus A2. Therefore intensity is how much? Intensity is A1 minus A2 whole square. So this is the intensity equation when phi is equal to 180 degree. Okay, so here you observe simply that. Now try to plot a graph between intensity versus phi, angle phi. So how this intensity versus angle phi is varying? And that means phi is equal to 0. If phi is equal to 0, what is the intensity we got? I is equal to A1 plus A2 whole square. So then after that what we have seen, phi is equal to 180 degree, then intensity is equal to A1 minus A2. What about phi is equal to 90? If phi is equal to 90, what is the resultant intensity? So that what we have to find. If you see phi is equal to 90, that means in this equation R is equal to square root of A1 square plus A2 square plus 2A1 A2 cos 90. Cos 90 means it is how much? 0. Cos 90 is 0. When cos 90 is 0, so this term is totally becomes 0. Then R is equal to what will happen? A1 plus A2, A1 square plus A2 square root of R is equal to A1 square plus A2 square. Right. So then intensity is equal to A1 square plus A2 square. So that is the intensity. See here, phi is equal to 0, I is equal to this one, phi is equal to 180, I is equal to this one. Then so at 0 it is this one, that means 0. This is a phi or 180 degree, or we can write this is phi. So this is same at 3 pi. At 3 pi also the same, I is equal to like this. Similarly 5 pi, 7 pi, like that, etc. So the same value of I will come. So similarly here is 0, and also at 2 pi also, 2 pi means 360 degree, 0 or 360 same. Similarly 4 pi also same. Similarly 6 pi, this is same. Similarly 8 pi, like this. Now in negative side also we can write minus 5, minus 3 pi, minus 5, same equation will come. Here also minus 2 pi, minus 4 pi also the same equation will come, because if you substitute here the same equation will come. Now how this graph look like? So if I plot this graph, this is 0, now 0, this is pi, this is 2 pi, this is 3 pi, like that. Here minus 5, here minus 2 pi, similarly here minus 3 pi. So what is the first? At 0, at phi is equal to 0, x-axis is what? Phi, y-axis is what? Intensity. At 0, what is the, this is the maximum, okay, so this is the maximum point. At phi, what is, at phi, what is the intensity? Intensity is minimum, that's why that minimum is, let's say it is, this is this point, A1 minus A2 whole square. And similarly at 2 pi, so at 2 pi again it is maximum, that means the same point. So this is the same length because the same value. At 2 pi it is same value. Again at 3 pi the same value is here. So this is same value at here. Similarly here in this also minus 5, the same level will come. This is the same value. The same value is here also. At minus 2 pi also the same value will be here. So here also minus, here also minus 1. Now simply you connect these dots. Then what could you get? So this you could get the curve is like this. Simply it go like this. Similarly negative side also if we extend, then it comes like so. Always it is in between 2 points. So this point is how much? A1, a value a1 plus a2 whole square. So this is a1 minus a2 whole square. So this is the graph between phi and as well as intensity. Intensity versus graph is, it is constant, it is going in a simple manner. Okay, at 2 pi 0, 2 pi 4 pi it is maximum, at pi 3 pi it is a minimum. So this is about the complete details about the superposition principle of the base.